multiplying found values by 2. And coming to the description, you are given an array of integers nums. You are also given an integer original, which is the first number that needs to be searched for in nums. You then do the following steps. If original is found in nums, multiply it by 2. Otherwise, stop the process. Repeat this process with the new number as long as you keep finding the number. Return the final value of original. So once again, I will simplify this description. What we have to do in the problem, the core part of the problem is we are given an array called nums with unsorted elements. Also, we are given another number, like another target value named original. Now the core part of the problem is we have to search and find the target value in this array. Once we find the target value in the array, stop right there, multiply the target value by 2, and again this original which we have known, which we have called it as target value, the updated target value gets updated. When we multiply the target value by 2, it gets updated. Now we have to find the updated target value also in the array. If you have found the updated target value, you once again multiply it by 2 and stop right there, stop the process when you don't find the updated target value, when you don't find the target value anymore in the array. What we have to return is return the last updated value, that is the recent updated value which you have found in the array. Now this is the problem. Now I'm going to show you how to solve this problem in 4 methods. So this is the test case given in the Leetcode problem. Now method 1, using Boolean variable. So the core part of this problem is just we have two options, yes or no. Yes or no. Yes, did we find the target value in the nums, or no, we did not find the target value in the array. Now what is this method 1? So once again I copy this array. I use a boolean variable known as found. I initialize it to the value of true. So now according to the problem, we have to repeat the process of multiplying the target value by 2 as long as we find the value in the array. Now here we initialized the found equals to true. Now we are using that in while loop condition. Now for keeping it simple, these both are the same, like, okay. Now this while loop executes as long as the core condition is true. Okay. Now I start iterating the array. If the present element is equal to the target value, I immediately update the target value by multiplying it by 2. Now here I missed a logic, so every time I have to update the boolean variable, so this one remains the same. Now I have to initialize a boolean variable inside the while loop, because every time I find the target value, when I get the target value, when I find the exact position of the target value, I don't move forward. I don't move means I don't iterate forward. I just break there and start from the 0th index of the array to find the updated value of the target value. Now, so I need to have another boolean variable as false. Now here, when I find the target value in the array, I multiply it by 2. So I also update the boolean value, means I update it as true. After updating, I break it, because as I told just now, I don't want to move forward. I have to start again from the starting of the array. Now this is all about the method one. So for a dry walkthrough of an example walkthrough, so let's take the same array. Wait a minute. And original is 3. Now when I start iterating, here nums of 0, which is 5, is not equal to 3. So I move forward. Nums of 1, which is equal to 3, here it's 3. So I have found the element, target element in the array. Now what I do is I multiply this element, this target element, which is original in this problem. Here it becomes 6. Now I just break. Have to start from the 0 index of the array. I have to start from the 0 index of the array. Now search for 6. So again, nums of 0 is as usual 5, which is not equal to 6, and nums of 1 as usual, which is 3, not equal to 6. Nums of 2 equal to 6, this is equal to 6. So I have found the element, the updated element in second index. Now I break it and have to start from the 0th index again. Now updated original is 6. Sorry, I have to multiply this 6 by 12 and 6 by 2, which becomes 12. Now the updated original is 12. I have to search for 12 in the array. Now as usual, it's the same. Nums of 0, nums of 1, nums of 2, nums of 3, not equal to 12. Now nums of 4 is 12, which equals updated original, which is 12. Now break it here. Sorry, we have to first update the original by 2, which becomes 24. Then start from the 0th index. Now search for 24, but 24 is not to be seen in this array. It becomes false. So the recent updated original value is 24. Last updated value is 24. This is the method 1. This is the method 1 of using boolean variable. Now method 2. Method 2 is using boolean array. In method 1 we have used boolean variable. Here we are going to use boolean array. This is also known as pre-processing method. Pre-processing method. So in this method we initialize a boolean array, say is present. We declare and initialize a boolean array. Here the constraints are, as we know, the constraints are from 1 to 1000. This boolean array works efficiently in handling the constraints. Okay, let me mention the constraints right here. So the length of the array, the elements, the original element value, all are in the range of 1 to 1000. So let it be 1001, because the boolean array has to handle the size efficiently. Now how does this boolean array work? So I start iterating the nums, the array called nums. Okay, let me copy this again. Okay, when I'm iterating this array, I also ensure that I fill up the boolean array. I fill up the boolean array. So first I have to fill up the boolean array based on the iteration of nums array. How does it work? Okay, it's like index. Now let the indexing start from 0. The indexing of boolean array also starts from 0. So index, let it be up to 24. Now the value. So index is the numerical value. This value is, to be precise, it's boolean value. Okay, here index is the element, value of the element. In this array I don't have 0, I don't have 2, but I have 1. So when this value is not present in the original array, you mark it as false. Now I have 1 in the original array, mark it as true. I don't have 2 in the original array, so mark it as false. I have 3 in the original array, mark it as true. So and it continues. So to be precise, if the element is not present in the original array, in the Boolean array, you mark it as false. You mark the corresponding index as false. When the current element is present in the original array, you mark the corresponding index in the Boolean array as true. Here 6 is present in the original array. I mark the index 6 in Boolean array as true. Now again another while loop, but here the condition is until my size is less than equal to 1001, because the maximum constraint is 1000. 1001, sorry, it's 1000. Original, this is the target element. Now when this entire condition is in while loop is satisfied, then only we can update the target element. So now connecting it to the example walkthrough, this now the original is 3, original is less than 1000, and it is present in Boolean array. I mean the index value of 3 is shown to be true in Boolean array. At index 3 the Boolean value is true. Here this while loop gets executed only when the original value is also present in the Boolean array. Then only you can update the target value by multiplying it by 2. And so let me show it. This value is present in Boolean array. Boolean array value is true. Now after updating I get it as 6. Again when you see the Boolean array, the value is true. Again the updated target value is 12. Now in Boolean array it's true. Again we have to update the original by multiplying it by 2, we get 24. Then here is the fix, here is the twist. At index 24, okay, let me be precise. Here index is the element, to be precise. The element 24 is not present in the original nums array. Hence in Boolean array also the corresponding Boolean value will be false. In 24th index in Boolean array it will be false. So when it is false, the moment this becomes false, the while loop stops, the while loop execution stops, and the process of multiplication by 2 also stops. Hence in this one the updated value is 24. Now method 3 is all about hash set. Using a hash set. In hash set we just use the lookup operation. We multiply the original element by 2 as we find it in the array, then continue this process. When the updated element is not found in the array, we just break the process. Now fundamentally we declare the hash set. We iterate the nums array. Again, here we have to keep adding the elements from nums array into the hash set. So one for loop for adding the elements from nums array into the hash set declared. Again, now we use a for loop for checking whether the hash set contains the target element or not. If it contains the target element, we just update it by multiplying with 2. Hash set, the structure of hash set is similar to the one used in mathematics. Now, according to the first line, I just insert all the elements from original array into this one. Now the searching operation starts. Search for original. This original 3 is present in this hash set, so update it. This 6 is present in the hash set, update it again, it becomes 12. This 12 is present in the hash set, update it again, it becomes 24. Now this 24 is not present in the hash set, so we break the process and the last updated value is 24. Now method 4 is sorting and linear scan. This one is very simple but works only for small constraints. If the constraints are large, this one doesn't work. Now the basic operation is we sort the original array. The advantage in this method 4 is, unlike method 1, method 2, method 3, we don't have to declare separate data structures or separate arrays. We have to just sort the array and just look for the updated values in a linear scan. Now using a for loop, the core condition is if the present element is equal to original, just update it by 2. Return original, and that's all. So coming to the time complexities, the time complexity of this sorting and linear scan method is O of n log n, and space complexity is linear constant time complexity. It's constant time complexity. Then for the third method, the time complexity is order of n, and space complexity is order of n. Because we are iterating the entire array, we are searching the entire array, like adding the entire elements into the hash set. Then the lookup operations. So it takes order of n for both time and space complexity. Now for method 2, which is Boolean array, the time complexity is it's the same, it's order of n, and space complexity is order of 1000, because I have taken the size of the Boolean array as 1001, but we finish our operations within the constraints, within the given constraints, that is 1000. So it's order of 1000. Now for the first method, the time complexity is order of n into k. This takes more time. The method 1 takes more time. So space complexity is the constant space complexity. This is all about solving this problem in 4 methods. Once again, I will review the methods. This one is, the method 1 is using a Boolean variable. So the difference between this method 1 and method 2 is, in method 1 we search and then mark. It's like we search for the original target value once and then mark whether it's present or not. But in method 2 it's completely the opposite. We mark all the elements, we mark all the values in the Boolean array once, and then we start the searching operation. This is called pre-processing. So this is the core difference between method 1 and method 2. In method 3, it's a hash set. We just use a hash set for finding whether the target value and updated target values are present in the hash set. In method 4, it's just sorting a linear scan. The difference between this method 4 and the above methods is, in the first 3 methods we needed another exclusive data structures for storing the results, for iterating the results. But in method 4 we just sort the array and look for the updated values. Now okay, let me show you the dry run of the method 4. Say this is our unsorted array. Now after sorting, I have 2, 3, 6, 7, 12, 24, 45. This is the sorted array. Now say my original element is 3. Now this 3 is present in the array in index 1. The updated original is 6. Even this is present in the array. Now the updated original is 12. Even this is present in the array. The updated original now is 24. Even this is present in the array. Now updated original is 48. This is not present in the array, so the last updated value is 48. Last updated value will be 48. So this is the dry run of the method 4. This is all about today's problem. And to the viewers who are viewing this video on YouTube, if you find this video lag, just keep it in 1.